Yeah, hello everyone. So today we are going to discuss with your Computer Network Laboratory first program in your part A NS2. One second. So the first program is as follows. Okay. So implement three nodes, point-to-point network with duplex link between them. Set the queue size, vary the bandwidth, and find the number of packets dropped. So here you need to create three nodes. Okay. And point-to-point indicates a dedicated link will be established between two nodes. That's it. From N0 to N1 and N1 to N2, and you need to create the duplex link between which nodes here, N0 to N1 and N1 to N2. In this thing, what I do is I take N0 as source node and N2 as destination node. Okay, and here they ask that set the queue size, vary the bandwidth, and find the number of packets dropped. And whenever they say packets drop, I need to go with what connectionless itself. So whenever I say connectionless, the type of the protocol what I'm using is UDP. The type of the protocol what I'm using is UDP. And whenever I say UDP, what happens is it is a connectionless protocol. It is a connectionless protocol. So here what I do is the properties of UDP I'll set to your N0 node, and what are all the properties of your null. So why null andre? So here what are the packet I'm going to send through your N0 node to your N2 node. N2 should not send any acknowledgement. That's why set the property null to your N2 node. And again, whenever you want to specify the application layer protocol for your UDP is what your CBR, constant bit rate, and the time generation. Whatever you are specifying, you need to specify through your application layer protocol, that is your CBR. So that CBR is been attached to what UDP. So this is what your program is. Okay, so we'll discuss how exactly it works. Okay, first what I'll do is go to your terminal, and you all know that how to do your program. So either use your gedit, okay, and the ns2 program you're writing in TCL script, that stands for tool command language. So it have an extension called .tcl. Okay, so it opens an editor. I already typed the program. So here, so what I'll do is, so as per the program whatever it is there, one second. Okay, I'll just show as per this thing. Yeah. Yeah. So here, what exactly I need to know, I do is this is your wired program. You all know that the steps of your wired program, the first and foremost thing for all your NS2 program, you need to create the simulator window. Okay. Or you need to create the simulator class. How do you create simulator? This is your main class where you're creating your topology of your network, whatever it is there in your simulator class. So you're using a new operator, and simulator class you have created is capsule. Okay, this is your main class, and all the other things you're going to create on this particular main class itself. So if you want to create the object for your simulator class, okay, what I can do is I can use your set command. And as I said that your ns2 program, whatever it is a combination of your TCL and C++. That's why it is called as object oriented tool command language. Means you're using the concepts of what you can say your C++, like your class, objects, and everything. So here, so for this simulator class, I can just create an object. Okay, how do I create an object? By using a set command. Set command always take two parameters. One is your variable name, and next is your value. So here, the simulator class, whatever it is there, for this object is what your ns. You need to give one space here, and s should be in uppercase. Hope you're clear with this. Now you have created a window. Okay, so then what happens is I can see my results in two different ways. One is your NAM, and one more thing is your trace file. So the animation kind of stuff, or the visualization of your topology, this visualization whatever it is there, I can just see in a particular file called as NAM. And every file will be having an extension. So your NAM file is having an extension called as NAM, one.NAM. So the file name is one.NAM I created. And open is a function, open new file, NAM file you open. And open in which mode? Your write mode, different access mode, read, write, execute. Why? Because I'm opening the empty file. Once I run the simulation, the output will be copied to this file. That's why I'm opening in which one? Your write mode. And the same way I can create an object for this file. How? By using a set command. Some object name I'll create, and I need to give one space. And once I do this, what happens is once I run my simulation, whatever I do, the results, whatever it is, it has to be copied to which one? This file. So where exactly the topology is present? In your simulator class. So what is the object here? NS. So dollar $NS. So what is a dollar means? It is going to evaluate or the content of your simulator, whatever it is there. I can just take by what? Your dollar symbol. That's it. So dollar $NS. I'll go to that. Nam trace all is a keyword. So there are n number of fields you get. Trace everything. So nam trace all single word. Nam trace hyphen all. These are keyword. And whatever you get in your topology, copy to which file? To one.nam. So one.nam ke object what is the object is name. So dollar $n. That's it. Hope you're clear. The same way trace file. Trace file is having an extension called as .tr. tr trace file. Same thing. Open function or tr. Open in your write mode and create an object something like t and I have created. So just give space here. Again, from this window, I need to copy to all to which one here? This file, one.tr. So go to that particular simulator window, $NS, trace all is a keyword. For this one, for nam trace all. For normal thing, trace all. That's it. Okay. Copy to one.tr. What is the object you have created is t. So $T. That's it. Hope you're clear with this. So this is a step. Next is you're creating your node. How do you create your node? In your simulator class, I can create what I can say subclass called as nodes. So how do I create nodes under just by using a command called as node? So where do I create? In your simulator class. So go to your simulator class $NS. So how to create your node? Node command is used. And if you want to name it, okay, so you can use your set n node. So n node is created. So 3 nodes I'll create. Same thing. See, 3 nodes I've created. Hope you're clear with this. Okay, so next I need to establish the link between what? N0 to N1 and N1 to N2. So today I'm passing how many parameter to establish your link? 7 parameter. Where the nodes are present in your simulator class. Go to that. So $NS. Next is the type of the link. That is your full duplex. How do you specify full duplex? Duplex hyphen link. Between which nodes? N0 and N1. So $N0 and $N1. Next is what? What is the bandwidth? As best specified 100 MB. M should be in uppercase. That is the convention of your TCL. Okay. So bandwidth, the throughput, it can be said. The amount of packets sent per second. Convention is what? Bandwidth? MB. That's it. M should be in uppercase. Next is your latency or your time delay. You can say the time gap between one packet and the other packet. So that is the thing I specified. And convention is what? Millisecond, both in lower case itself. And the last parameter is the type of the queue. That is your drop tail. Means whenever the buffer is full, drop from your tail end. So 7 parameters. In your simulator class, type of link, between which nodes, next is your bandwidth, next is your latency, and the type of the queue. So I established between N0 and N1. And next same way you establish between what? N1 and N2. That's it. Hope you're clear. And also they said that in your program, set the queue size. How do you specify the queue size between your source node? Okay, how do I specify? The nodes are present in your simulator class. Go to that $NS. Queue limit is a keyword. Between which nodes? N0 and N1. The size of the queue is what? 10. The size of your queue is what? 10 bytes. That's Hope you are clear with this. So now, whenever say the packets drop, you need to go with what? UDP connection to transmit the data. The data has to be communicated from one node to the other node. You can use your transport layer protocol, either TCP or UDP. So, but here drop, that's why I'm going with what? UDP. So here, the protocols in your NS2, it is called as agents. So same way, new operator, agent, A capital / in your agent class, I'm creating a subclass called as what? UDP. User datagram protocol, all in uppercase. So for this, I can create an object by using what? Set command. That's it. And now what happens is the UDP protocol, whatever I created, I need to set this properties of UDP to which node? Your source node N node. So how do I do that? The node is present in your simulator class. So go to that $NS. Attach agent is a keyword. Attach agent. What you're attaching to your N node, you're attaching UDP. See $N. What you're attaching is UDP. For UDP, what is the object you create is U. So $U. So here what happens is attaching is a thing, but the properties of your UDP, whatever it is there, or what all the features is there, that will be taken by which one here? N0 node. N0 is going to bear has what? The UDP source node. UDP source node. And the destination is which one here? N2 node. So here, what is the agent or protocol? What I'm using is null. Why? Because for whatever the data I transmit from UDP source to UDP destination, it should not send any acknowledgement. That's why the agent what I'm creating is null. So same way, new operator agent main class, in that subclass I'm creating called as null. Only N should be in uppercase. Create an object by using a set command. And same way, go to your simulator class $NS. Attach agent is a keyword. To which node? For N2 node, I'm attaching which one here? Null. So for null, what is the object I create is N. So $. That's it. Hope you're clear with this. Now what happens is the N2 node is going to act as a destination of your UDP. So whatever the packet you get, it doesn't set any acknowledgement, null. That's it. Hope you are clear with this. And as you know that for any particular transport layer protocol, there should be application layer protocol, and also it is called as time generation. For UDP, the application layer protocol you are using is which one? The CBR. So here, so same thing, new operator application. In this application class, there is a subclass called as traffic. A should be uppercase, T should be in uppercase. In that, there is an application layer protocol called as CBR. So CBR is a subclass under traffic class, and traffic is subclass under which one? Here, application. So CBR uppercase, constant bit rate, all in uppercase. So create an object by using a set command, and then what happens is this CBR should be attached to your UDP node. So the object for your CBR is what? CB. So $CB attach agent to which one? To your UDP. For UDP, what is the object identity? Is U. So that's why $U. So CBR object is CB. So CB attach agent to which one? Here, UDP. So UDP object is U. That's it. Hope you're clear. And also you can specify the packet size and your interval time and everything. How do you do that? Through your application layer protocol. So CBR. For CBR, the object is what? CB. So $CB set command is used. Packet size underscore. So this syntax is called as camel case syntax. In your what I can say C++ it comes. Okay. So while you setting exception handling and everything, this underscore and everything. So packet size. So packet size S should be in uppercase, underscore something like 5000 bytes. I say that's it. And next is the interval time between one packet and the other packet. Same thing. Go to your CBR. The object is CB $CB set interval underscore something like 0.001 second millisecond. No need to specify the convention here. 0.001 is the time gap between one packet and the other packet. Now I need to connect the source and your destination. So how do I do? Simple things here. $NS connect which one? The UDP and null. So for UDP, what is the object declared is U. Now for null, object is null. So $N. That's it. So this connect you are done. Hope you're clear with this. Then what happens is same way. How I can start the event by what? Application layer protocol itself. So for that, what you can do is you can use your at command. So $NS, you go to your simulator class. At is a keyword to specify execution later, executing at user specified time. So at 0.1, you're saying your application to start. Application is what? CB. Object is what? CB. CB start. Start is a keyword. That's it. Again, you can specify the stop time when you want to stop. And next you can specify total finish time. So $NS at 2.0 finish. So whenever you call this finish, it goes to your finish procedure. Okay. So here it starts with what? A keyword called as proc, and the procedure name is what? Finish. And I'm not passing any parameters. So flower braces, empty parenthesis, and the opening block of your procedure should be in the same line. And what all the variables I've declared? What all the variables I've declared is NS, NMT. So I'll just make all thing as what? Global. Means I can use throughout my program. That's it. Next, what I'll do? $NS flush trace. So in your simulator, as soon as I execute, what I'll do? I'll just give flush trace. So what does it mean? So flush trace, what does it do is, once I run my simulation, the output of this particular files, whatever it is there, it should be dumped to which one here? It should be dumped to these two files. The files, whatever I opened, empty files will be there, right? It will be dumped to your one.nam and one.tr file. So that flush trace is used to dump the results after running your simulation to those files. After dumping the result to those files, what is the use of those files? So close that one. Through what object? For your trace file, the object I've created is what? T. For nam file, the object I created is nm. So close $T and close $NM given. And again, if you want to check it out, your animation, your visualization and everything, execute is a command, exec. What you're executing? Nam file you're executing. And the file name of your nam you're specifying your program, that is your one.nam you're given, so that you give, and ampersand execute in your background. Exit 0, successful completion, close of your procedure. So remember, the opening block of your procedure should be in the same line. I'm not passing any parameter, leave empty. That's it. So now the way to execute your NS program is what? $NS run is a command. Run is a command. That's it. Hope you're clear with this. So this is as per the topology, whatever it is. So now what I can do is, how do I run my program? This is in your editor. So save the program and quit from your editor. Save the program and quit from your editor. So you need to go back to your terminal again. You need to go back to your terminal again. And here, how to compile my program? NS File name is what? 1.tcl. So file name with an extension I should give. So this is how I'm going to compile my ns2 program, ns1.tcl. So you can just see now, you can see your animation file will be opened. Okay. So one second. So animation file will be opened. So one second, I'll just close and I'll open. If any errors, it will display here itself. So Control D I'll press. So go back to your terminal. So one second. So what I can do is I'll just run my simulation ns1.tcl. So once I compile, see, I'll get my simulator window. So this is my the output NAM file, whatever it is. So I can drag and drop the nodes wherever I want. So go to edit and place like this. So here. So this is your three nodes I've created: N0, N1, and N2. This is your source, this is your destination. So these are all your menu button. So this is your rewind, fast rewind, normal rewind, pause, play, and this one. So I'll just go with now play. You can just see at 0.1 as specified packet flow. See, packet is flowing from what? 0 to 2, and there is some drop of your packets. You can't count how many packets are dropping. See, so this is your dropping of your packets. This your dropping of your packet. So to some thing I specified in my bandwidth and queue limit, for this your, see how many packets are dropping and how many packets are flowing. So once I do this, what I can say is I can see my results. I can see my results. How do I do? You're just seeing your NAM file, and one more way to see your results is your trace file. Get it? The trace file name is 1.tr. So I'll open. So just see. So totally there will be 12 fields in your trace file. How many fields will be there? 12 fields will be there in your trace file. And see, your trace file itself is how much large? Trace file itself is how much large? It is too large, right? So the question is, find the number of packets dropped. How do I do that? It's very difficult. And what all these particular trace files, I'll let you know. So what all this particular trace file here is, okay. See, there are 12 fields totally in your trace files, and here the explanation as follows. Here, event is your first file, time, from node, to node, packet type, packet size, flag, flow ID, source address, destination address, sequence number, packet ID. So in your first field, whatever it is there, you can just see what event. Okay, so here we can just see another what all you can see plus, minus, and somewhere you can also see what you can say is, see R, you can see S and R, you can see, and then you can see it's something called as D. You can just see R and all it is there, and also you can see some packets are dropped. Okay, so your trace file itself is so huge. You can see here something called as D. So there are four things you can see. What all the things is, either it can be your plus, your minus, or it can be R, it can be D. So R is nothing but the packet is been received. The packet is been received by the receiver. So D is nothing but the packet is being dropped. So plus is nothing but in queue. Under you place the particular packet in your queue. So minus means DQ, means you are not placed the particular packet in the queue. You are not at placed the packet in the queue. That's it. So these are the four things what it says. And next field it says time. At what time you are sent the packet. At what time you are sent the packet. And next is your from node and to node. From node indicates from where, node number. That's it. In your topology, node number from node, and for where it went, from node 0 to node 1 it went. That's it. Next is your packet type. So packet type, either it can be your CBR, or it can be your TCP. So CBR means UDP packet, TCP means it is TCP packet itself, the type of the packet. Next is your packet size. So how much packet you're sending, so size of your packet, something it will display. And next is some flag bits will be there. You're not using, not worry. And flow ID, some coloring that also not specified. And next is your source address and destination address. So that will be in the format of IP address 0.002, something like that is your source node address and destination address. And next is your sequence number and your packet ID. So packet ID indicates a particular ID for a particular message. So suppose I'm sending two messages simultaneously from the same source to same destination. I'll send hello, good morning, hello, good morning. I'll divide this into 3 frames. Hello, good morning. So both the message, totally 6 frames. Simultaneously I'm sending. So whenever it receives by the receiver, it as it is, you're going with what UDP, right? As you're going with a UDP, the packet will be received in an out of order fashion. You need to shuffle. So in order to shuffle, you need what sequence number. But hello, hello, twice I got. Good, good, twice I got. To which particular message this particular frame belongs to? To identify that packet ID is used. That's it. So these are the 12 fields that are present in which one here your trace file. And obviously you can see here it is very large in order to see the results. So in order to overcome with that particular problem, so what I can do is I can just go with a particular file called as awk script. I can just go with what a particular scripting language. Okay, so what is that particular scripting language? What does it do normally? So it is a pattern matching and processing tool. So this is separate awk script I'm writing in order to get only the output of my trace file, whatever it is, in order to filter that particular thing. So this awk programming is also called as extracting tool. So what does it do is whatever the particular pattern you're going to specify is going to extract only that particular pattern and print the results So this is called as pattern matching and processing tool, or you can say it is an extracting tool. So what does it do? It's going to search for the entire file, and whatever the command you're given or whatever the keyword you're given, it's going to search the particular keyword and it's going to take an action. Whatever the action you are specified, that will be taken. That will be taken. So the syntax of your awk script, how exactly it is there, and awk script, whatever it is there, you need to write in the format of, again, you need to write a program, right? Again, when you go to your gedit, and the extension for your awk script is what? awk. That's it. And the structure of your awk script, it consists of three things. One is your begin section, the rule section, and the end section. And the begin section, all in uppercase begin. The opening block should be in the same line, and this is your close of your begin section. Here you can go with any variable declaration. You can go for what? A variable declaration or any particular header files if you want, you can specify here. And the rule section, whatever it is there, you need to specify the rules, what exactly you need to extract. So how the rule section will be there? There are two things. One is your command, and whatever the action you want to take, that should be enclosed within your parenthesis. That should be enclosed within what your parenthesis, flower braces you have to specify. So that should be enclosed within what? A pair of parentheses. So here you need to specify the rule section. The rule section is having two things. What condition? For that condition, what action should be taken should be specified within your flower brace. That's it. And next is your end section, all in uppercase. You can print the results of this. So here, what I can do is, so I'll just open my trace file now. Trace file you are already checked. So now what I can do is, I can I'll write my awk script. How do that? Gedit file name.awk. Already I've written the program. So awk.extension. So it is having how many sections totally? 3 sections it is having. So totally it is having how many sections here? 3 sections it is having. So what you need to do is, one second. I'll just close this one. Okay. So 1.awk here. Total is having how many? 3 sections. So begin. I'll take one variable. So what exactly I need to do is I need to count the number of packets dropped, right? So I'll just use one variable, drop equal to 0. So begin section, any variable declaration, any header files, I'll specify. Begin uppercase, within a pair of block, I'll specify a variable called as drop, so equal to 0. And what is the condition I need to check in my trace file is? What is the condition I need to check in my trace file is? So here, so normally what I need to do is, I'll just open my trace file. You can just see here the output, whatever it is there. So yeah, so you can just see in your trace file what happens is, you can see 12 fields, right? And in that, what happens is I need to find what all the package that's been dropped, what all the package that has been dropped. How do I check that one? So it's very difficult in checking with that particular thing. So what I do is I'll just write my awk script in order to take only the package drop. So in your first column in your trace file, so either it can be plus, either it can be minus, or it can be r, or it can be d. So here there is some special operator called as positional parameter, that is called as $1, that is called as what? $1. So here $1 is just here. So $1. So this is going to indicate the first column, okay. In your first column, if it is equal to d, what you will do is drop plus plus, you are going to count that one. So this is your rule section. So this is your rule section. Hope you are clear with this. And this is your end of your rule section. So you open, and this is your close. And for the if loop I've done. And next end section, what I do is I want to print how many packets is being dropped. So the number of packet drops. So printf statement, so equal to percentage d, and in which variable it is it? Drop variable it is it. So this is how the awk script I have written. So now what I need to do is, in order to pass this particular awk script, to which one here? To your trace file. Okay, so what exactly I need to do is, how do I run my what you can say command? So awk command minus f is an option. The output of one file is passed the input to the other file. To do this one, what I'm doing is I'm just using this command. So file name dot talk, I've just given one dot talk, pass to which one here? To your trace file. So that is how you're going to do. So here what you can do is, so awk command minus f option. So one dot awk awk script, whatever it is here, I'm passing to which one here? To your trace file I'm passing. So see here, the number of packets dropped is how much here? 6,330. 6,330 edition. Hope you are clear with this. And what is the question they asked is, find the change the bandwidth, queues limit, and find the number of package drops. So now we can increase your things, whatever it is there. So what I'll do, I'll go back to my program. Okay, go back to my program. So now what I'll do, I'll just decrease. So here what happens is, you give your receiver link bandwidth, that is n1 to n2, whatever it is there, it is too less. And queue limit I'll decrease to 5. So I'll run my program. So save it, exit from your editor, and again run your simulator. How do I do that? So ns file name 1.tcl. So here this is the thing. So you can go for edit, and you can move your nodes wherever you want. Okay, now you just press this play button. So at 0.1 second, so the packet will flow. See, more number of packets is dropping. So after you do this, okay, you just see I've decreased what you can say queue limit, and also the receiver bandwidth. The receiver bandwidth has been decreased. Now the package dropped, you can check it out. So I'll just run straight away the awk script. See, so previously it was 6,330. Now it is out 7,393. Hope you're clear. Again, you can change. Go to your program. Okay, and I'll just give now 1 MB. So the best bandwidth what you can say is, you can give 1 MB, and also you can change this packet size and your interval time and everything. So control S, and again the queue limit I'll change to. So I'll go back and I'll run my program. So again, see, so just use your press button. So the packet will flow here, drop occurs here. So again, you can check here the trace file. So the packet drop is how much? 8,243. So like this, you can write the output here. So what you do is, the output, whatever, whenever you're writing, okay, so write for 3 things. So see, I specified here. So awk script I specified. So the output, whatever it is there. So like this, some for 3 different things: 100 MB, 1 MB. So what is a packet dropped? What is a packet drop? Something for this, I've got something like 6,330. Okay, I've got something this one, and now I decrease this one, and something you got something like 7,393, and then whatever the sender bandwidth and receiver bandwidth you have set, and something like last you got something like 8,445. So like this you need to write. Okay, so change your bandwidth of your receiver link, reduce, so reduce less than 1 MB you give, and check, and the queue limit whatever it is there. So like this you need to write the output. Hope you're clear with your first program, whatever it is there. Hope you're clear with this. So this is your first program. So thank you guys. Okay, hope you understood. So here I stop recording your first program.